Okay. Okay, this is presentation one. This is test video, test audio, test PowerPoint presentation. So this is a quick PowerPoint presentation about Ansible playbooks and Pure Tech. Should say Pure Tech, not Pure Storage. Little intro about me. My name is Andy Parsons. I am from America, if you haven't already guessed. Recently moved to the APJ team as a new Tech Solutions Architect. My role is supporting containers, DevOps, virtualization, pretty much all the things. I actually have a pretty broad array of skill set. Started out desktop support and worked companies like Netscape, desktop support, system engineering. Worked for companies like Facebook, the Air Force, Army, Navy, Air Force, ASE, which is a chip company, and now here at Pure Storage. Had roles from system engineering to network engineering to solutions architect. Kind of my areas of interest background are networking, virtualization, automation, kind of open source stuff like that. So yeah, Ansible automation. So we're going to talk about Ansible today. It is a product that I love. Why should we automate all the things? Because manual sucks. You know, a lot of you guys out there have gone from a manual process to an automated process. You know, maybe you're building switch configs using files. I think everybody's probably done that at some point in their career, where they're copying a flat file into an environment, editing the name, IPs, management, and hitting go. The challenge around that is, you know, maybe the guy before you didn't use the right IP address, or maybe he tagged a VLAN incorrectly, and when you set things up, something breaks. You know, it's slow. In a DevOps environment where you don't have the limitations of change control and things like that, you can typically move a little bit faster. But if you're in, say, a bank or a retail commercial outfit where there's a change control process for every little thing, if you want to make a change to a switch and add a VLAN, if you want to, you know, add a host and present a LUN or set zoning on something, those changes can go through a process, and that process can be not only slowed down by the manual process, but slowed down by the change control process. Some manager needs to sign off on this, or a director needs to see what the business impact is before he's going to allow you to do something that may or may not be impactful in the business, and you have to convince them, and that can slow things down. Copy and paste. Everyone's done it. You know, if you're zoning an MDF switch, you probably have a config where you create your zone sets and files, and then you add your target initiators and your targets and your initiators. Excuse me. And probably everybody's done this, where you have a file and you just kind of go in, edit it, and you update it, and then you reload it. And if something breaks, you go back to that manual file. Yeah. MDS manual, painful. Especially if you've got, you know, a large director class switch with multiple zones and multiple zone sets. Pixie is awesome, but wait, we're not done. I think everybody in their career has built a Pixie environment. They built a Pixie server, Pixie boot your Linux, CentOS, VMware, awesome. Maybe you even have a Kickstart file that builds it. But wait, how do we add it to the cluster? How do we present volumes? There's always more process, which is awesome. But usually it brings it to a state where it's almost there, but not all the way there. Storage. I've got hosts, I've got host groups, I've got WWNs. I've got to glue them all together. If we're doing this manually, you know, oops, I keyed in the WWN wrong. I added a 1 at the end or an A at the end, and now that zone and that host is not zoned. You know, if you've got 20, 40, 100 hosts, this is very time consuming. 20 is probably the limit of manual doable. 40, 100. We're talking you're spending hours on a process if it's just loading OSs. If you have to stand in front of 40 hosts and hit the space bar so Pixie will continue and select that menu, that can be very time consuming. Moving parts, lots. If you think about that whole process where there's not only the people to approve the change control from the director or the manager saying, yes, you can do this, you have to do it on a weekend, to the teams involved, networking and the storage team, maybe the virtualization team, and all these guys, they have an impact, they have a say, they want it done a certain way, and they all are going to weigh in on how it's done. And when that process is broken, there's probably 3 different people that may be involved in repairing and troubleshooting that process, which can cause headaches and delays. So I'm going to talk about PureTech, which is the lab that I supported over the last just about 3 years. So in the early days of PureTech, everything was manual. We started out with 12 racks, and they were all very different. You had solutions engineering racks doing flash stacks. You had VMware racks that were doing VMware clusters. Some of them were iSCSI, some of them were fiber channel, all kind of siloed in their own little island. You could think of each rack as kind of its own data center within the data center. It would have its own network that was segregated from everything else, a couple of VLANs in the rack, and they were all built manually. We have one, you'd have a customer in each rack, they could handle and manage that themselves. That's fine when you've got 12 racks, but what about when you go to 100? Now, as PureTech expanded over the years, we added more products, FlashBlade being one of them, Object Engine being the most recent one, and the team of consumers grew from a team of maybe 8 or 10 guys to more than 50, and they all had different use cases. Some guys were doing VMware, some guys were doing containers, some guys are doing OpenStack, and some guys are doing FlashBlade, Object Engine. The list goes on, and they all have different requirements to some degree. They're all consuming a product of infrastructure. So we have security concerns, we have network concerns. Lots of different variables. This is an environment with over 700 compute nodes today, all of them which have, Linux OSs of CentOS, Ubuntu, Oracle, Red Hat, VMware, Microsoft, even different flavors of Microsoft, 2012, 2016, 2019. 112 arrays. Probably a baker's dozen of FlashBlades, and then various versions of FlashArray. FlashArray purity code from 4.6 on up to the most recent 5.2 versions, all being tested in different places. How do you manage that? How do you, make sure that there's not a problem with a system? Obviously, I throw up this Pure 1 board. This is really our dashboard that says, what are the health of these arrays? What's problematic? How, what do we need to look at? Big time saver for us. 30 flash stacks. You can look at a flash stack as a data center in itself. It's got, depending on the configuration, there may be many VLANs inside of it. Some of them are routable, some of them are non-routable. They have their own storage fabric, they have their own network fabric. Some of the flash stack builds that you've probably seen, CVD, VVD, are doing, BGP routing north and south, and then east and west outside of the rack. They're using virtualized networking like Nexus to segregate and control traffic. They'll have an application stack, an infrastructure stack, and they're very siloed. So lots of challenges around that. There's got to be a better way. Managing all this manually, you'd need a team of a dozen guys. We had 3. So PureTech and Ansible, let's simplify things. Let's have one way to do everything, and let's make it repeatable so that it saves us time. FlashBlade hurt my network. What is that about? So in the beginning, or I would say probably about 2 years ago, when we introduced FlashBlade, we brought FlashBlade into the lab. It hurt the network, and what I mean by that, FlashBlade, you can almost look at it like a vacuum. It can ingest large amounts of data, and it will find vulnerabilities. Maybe you have a spanning tree loop that's dormant, not really doing anything until a node tries to attach storage to it and ingest large amounts of data. This will find those vulnerabilities in your network. It will find those choke points. If you're extended, in the early days, we extended layer 2 all the way out to the lab from the core router to every single rack. And there's, big challenges behind that. A node can create a loop or a broadcast storm, and it really it hurts. So network automation with Ansible really helped to streamline that process. You look at, we had 100 racks, so there was about 8 rows of server racks with MLAG pairs of switches per rack for distribution. We had a spine leaf model and various versions of code. So we were running an Arista spine leaf network. So, you'd have a pair of switches. One's probably running 4.8, one's probably running 4.10. And that causes problems. Dissimilar OSs in the switch architecture. That was one of the first things that we standardized, was being able to standardize the OS version on all the switches, being able to standardize the config on all the switches. Because, we'd have no two pair were the same. Everyone had a different MLAG config because, manual, right? One guy would build this on a Friday, 3 months later, he would build this on a Monday, and there's going to be drift. People are making changes. And when you make manually changes, sometimes you forget to write the config. Maybe there's a power outage that shuts off the data center power, God forbid, and someone forgot to do a write mem, and lo and behold, all the config changes are gone, and now that whole pod can't get out to the network. So having a standardized process using automation really helped us in, being able to do things like write playbooks that write mem configs and run them on cron tabs, so that every day we would write the memory so that there was no issues if there was an outage. And that's usually a case of that's a problem that someone had, and that was how it was fixed. Compute. So Pixie Boot is awesome. For most people, they might have Pixie working great for Linux and VMware, and maybe they have Windows, or maybe they have experts in one or the other and not have issues with the other one. We've seen Pixie doesn't always play well with all of the above. And it works. It may take you 90% of the way there, but not all the way there. MBS. So with 100 racks of gear, we had probably 50 SAN fabrics. Since each pod was its own pod and the customer would make their own changes, in the early days, we had inherited lots of gear, so we had lots of sets of MDS. Zone set, activate all the storage. Pretty challenging. With Ansible, we're able to ingest all of our fabric from, we actually use a SQL server that stores all of the WWNs for hosts and storage, and we can pull from that repo all of the Ansible, or all of the WWNs, so that we know that this serial number for this host has these WWNs, and we can map those to this storage array in this SAN fabric. And because we're using a playbook, it doesn't care about any of the configs. All it knows is these hosts that are with this variable, plug it into this fabric. Ha, Pure FA host group and volume. Oh, how I love you. So these are three pure Ansible playbooks or modules that we use today. So FlashArray host group, and volume. So you could think of these are the three things that you would need to glue hosts to storage. So you create a host, you add it to a host group, you create a volume, you add the volume to the host group. Voila, you've got some storage that you can do something with. With Ansible, it really gives you the luxury of you can create variables of hosts, of volumes, and everything, and glue it all together and present it. And it's a rinse and repeat process where, I want to add a volume. I can just add a variable to a playbook, or I can add it to a script or to a CSV or to my control database, run a play. And because everything's already pulling from a source of truth, done. So yeah, very time-consuming process made easy with Pure and Ansible. Now, there's a lot of different storage platforms out there. There's a lot of different automation tools out there. Ansible is one that Pure is very active in the community. We are currently adding features as we release features in Purity, like Snap to NFS from FlashArray, which is due to be released in the next upcoming code in 2.8. We're actively testing these features, working to resolve bugs and pushing them to newer versions of Ansible. So it's a very active community. You can actually go online at GitHub and you can see what features we're adding and things like that. So yeah, that's my presentation on Ansible and PureTech. Thanks for your time, and let me know any questions.